Welcome, stargazers. Can you believe it? Picture a celestial event so massive that it casts shadows on Earth, visible even in broad daylight. That's the spectacle we might be on the brink of witnessing in the Orion constellation. The star Betelgeuse is acting mysteriously, hinting at an impending supernova explosion that will light up our sky like never before. But when will Betelgeuse go supernova, and what will it look like? According to scientists, what secrets might this stellar event unveil? Join us as we dive deep into the details of what's really going on with Betelgeuse and the impact it might have on Earth, and perhaps the entire solar system. Located approximately 650 light-years from Earth in the constellation Orion, Betelgeuse is not just any regular star. It's a red supergiant, one of the most luminous stars known to us, shining with a brightness over 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not only for its brightness, but also for its history and significance in human culture. Named after the Arabic term Yad al-Jawza, which means the hand of Orion, Betelgeuse has been observed and documented by ancient civilizations for centuries. It has been a guide for travelers and a point of wonder for stargazers, with its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star dwarfing our entire solar system? To provide some perspective on the sheer enormity of Betelgeuse, if it took the place of our Sun, its edges would extend all the way to Jupiter. How can a single star achieve such colossal proportions? At 10 million years old, it's a lot younger than our 5-billion-year-old Sun, but Betelgeuse's massive size means it consumes its materials at a much faster pace, predicting a shorter lifespan than that of other stars. Now, this celestial behemoth, spanning a volume large enough to contain more than 1 billion of our suns, is nearing the end of its life cycle. When stars of such magnitude reach their twilight years, they don't just fade away, they go out with a bang. A supernova explosion that's beyond human comprehension in terms of its energy and brilliance. Such an event has the potential to outshine an entire galaxy, casting shadows of brilliance across vast cosmic distances. The last time Earth witnessed a supernova explosion this close was in 1604, long before the invention of modern telescopes. This event, known as Kepler's supernova, was the last supernova to be observed in our Milky Way galaxy with the naked eye. Visible for over 18 months, it was brighter than any other star in the night sky and even remained visible during the day for several weeks. What mysteries do these stellar remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, documented the appearance of this new star. Intriguingly, remnants of this explosion, in the form of an expanding debris cloud, can still be observed today with sophisticated telescopes, giving us insights into the violent ends of massive stars. Historically, supernovae have been rare observers on Earth. But imagine, for a moment, a stellar detonation so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event would charge our atmosphere, potentially impacting satellite operations and possibly even the climate. Betelgeuse, with its unpredictable dimming patterns, suggests it might be gearing up for just such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Just recently, astronomers made a startling revelation. Between October 2019 and early 2020, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had been consistent for centuries, began to decrease significantly. This sudden change was so evident that even casual stargazers noticed it when comparing Betelgeuse to other stars in the Orion constellation. This means that we're not just centuries away from witnessing its supernova explosion, but perhaps mere decades, or even less. By April 2020, astronomical observations reported that Betelgeuse had returned to its standard luminosity levels, leading many to believe that the period of anomaly had ended. In a surprising twist, the following months witnessed Betelgeuse's brightness amplifying by an astonishing 50%. Such notable fluctuations, while typical of variable stars, were unusual for a star like Betelgeuse, which had predominantly exhibited predictable luminosity cycles. The sudden and intense surge in its brightness thrust the star back into the spotlight, sparking discussions about its immediate future. But what caused this abrupt change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a celestial curveball? Stars are not merely twinkling dots in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness variations can be anticipated, akin to the rhythms of Earth's seasons. Throughout its stellar lifetime, Betelgeuse maintained a fairly consistent 400-day luminosity cycle. However, with the Great Dimming, it seemed to defy its established behavior, challenging our comprehension of the celestial phenomena above. Now you might be wondering, are we on the verge of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a colossal celestial volcano, suddenly erupting and expelling a vast amount of its matter into space. Previous observations from the Hubble Space Telescope revealed that Betelgeuse had previously expelled a tremendous amount of its surface material into the cosmos. This expulsion, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such events can result in the formation of a dense dust cloud around the star, influencing its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could elucidate its subsequent return to regular brightness levels. Either way, these recent events suggest a star that's not finished surprising us. Many speculate that Betelgeuse might be approaching the twilight of its life, a supernova event, an astounding burst of energy that can outshine an entire galaxy momentarily. This phenomenon occurs when there is a sudden change in the star's core. Changes can arise if a star absorbs too much matter from a neighboring star, or, in Betelgeuse's case, it could be from the exhaustion of its nuclear fuel, which cascades its mass into the core, setting the stage for a cataclysmic collapse. But what drives a massive star like Betelgeuse to its demise? Born from the gravitational collapse of gas within molecular clouds, stars, like Betelgeuse, kickstart their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. But as stars run low on hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is marked by the star's expansion into a red giant. With time, as helium reserves diminish, the star undergoes further expansion and shifts into other burning phases, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these transitions, given the immense gravitational pressures at play. Then comes the climax, when iron starts forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size and creates an implosion followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the brink of an explosive end, or just biding its time? Recent research by Japan's Tohoku University suggests that the star might be in its carbon-burning phase right now. Lead researcher Hayasuk believes that the core might collapse a few decades after its carbon reserves dry up. But not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing that scientists do agree on, regardless of these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. Yet pinning down the timing of this event remains a cosmic guessing game, with bets ranging from mere decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains unchallenged: the very nature of our observations. When we look up at the starry expanse, there's a subtle paradox we often overlook. This paradox is rooted in the very nature of time and light in our vast cosmos. Stars and celestial bodies are so distant that their light takes a monumental amount of time to reach our eyes. For instance, light speed, while being an astounding 186,282 miles per second, still has its constraints. Consequently, the light from remote stars and galaxies takes its sweet time to traverse the vastness of space before it graces our sight. Gazing at Betelgeuse, you're actually witnessing a spectacle from 650 years in the past. To put that in perspective, when this very light embarked on its journey toward Earth, the Renaissance was just dawning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a cosmic time capsule, granting us insights into its distant past. And if, for argument's sake, Betelgeuse had already exploded in a magnificent supernova, we'd remain oblivious for another 650 years. So, while we discuss and predict its impending supernova, somewhere out in the vast cosmos, this monumental event might have already unfolded. We're just waiting for it to traverse space and time until it reaches our eager telescopes. The recent revelations around Betelgeuse have led to fervent discussions in the astronomical community, with comparisons being drawn to another sensational discovery from earlier this year, SN 2023X. This recently observed supernova, occurring in a galaxy neighboring the Milky Way, reminded many of the fascinating dynamics and unpredictable nature of the universe. SN 2023X was unique in its own right. Located several million light-years away, it showcased an intense display of brilliance that momentarily outshone its host galaxy. But what made it particularly interesting to scientists and casual observers alike was its uncanny resemblance to what many predict will be the fate of Betelgeuse. The spectrum, intensity, and aftermath of the explosion offered a tantalizing glimpse into the processes that these massive stars undergo as they approach the end of their life cycles. For many, SN 2023X served as a preview of what we might witness if and when Betelgeuse meets its explosive fate. The sequence of events may look similar to what was witnessed with SN 2023X. In addition, the connection between these two celestial events underscores a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova such as SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the tangible and scientific, the explosion would have profound effects on human culture. The sky, observed and revered for millennia, would have changed. This alteration would lead to reflections on impermanence, the vast scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemerality of existence and our eternal quest to comprehend the